Hey, algebra students, let's step up the concept of two-step equations with some advanced level practice. So first of all, I see is -3 a solution to z squared minus 8 equals -1? Now, I got a lot of students who say, this isn't really that challenging of a problem, Kate. Give me something good, and they do something incorrect here. So I want to show you what it is. I grab my red pen. Don't put this in your notes because this isn't going to work. But they look at this equation, which I like. There's the equation z squared minus 8 equals 1. And they go, hey, if -3 is a solution, I ought to be able to plug it in for z. I like that too. That's true. But here's where they go wrong. They go wrong in their substitution step. They say, okay, I'll turn z into -3. I'll square that. I'll subtract 8 and see if that's equal to 1. That's all that symbol means. The equal sign with the question mark, guys, just means I'm asking myself a question. I'm not sure if these two sides are equal. I'm checking it out. That being said, I don't think you'll have that symbol on the GED, but math teachers use it because it's a legit verb. It's a question verb. All right, that being said, then they'll plug this into their calculator. They say, okay, -3 squared minus 8. And their calculator says -17. Again, this is wrong. Don't write this down. And then they go, hey, that's not equal to 1. So is -3 a solution? No, it's not. And the student who did that, there's something really important that they don't understand about when you plug in negative numbers. Okay, so when you plug in, I'm just using common language for when you substitute this step, okay, guys? When you substitute negative numbers into what we call exponential expressions. That just means like an expression, a part of math, a piece of math with an exponent on it. Okay, so basically I'm putting a negative number into an exponent, then I need to know something. I need to know that exponents are super duper weak. This exponent square, the way I've written it right now, is only working on the 3. It's only working on the 3. If you want that exponent to work on the entire -3, which you do because I'm supposed to square all of z, not part of z, you need to use parentheses. Okay, write that down, stamp it in your memory. I don't know, maybe tattoo it on your forehead, guys. That's how often students forget it. And the GED knows you guys forget it, so they love to feature it. Okay, so this is what you're going to do instead. You're going to take -3. Well, let's not use black though. Okay, you're going to take -3 in parentheses, put it in parentheses, and then square it and subtract 8. And we're going to ask if that's equal to 1. This says take all of our x, -3, and square it. Okay, so write this in your notes, you guys. When plugging negative numbers into exponents, you must put the negative number in parentheses. Now, type this into your calculator, this entire expression, because I'm feeling lazy. And let's see, parentheses -3, close parentheses, square, and subtract 8. And this is a different problem, a different answer. I get 1. And is 1 equal to 1? Well, heck yes, it is. So yes, -3 is a solution to this equation because when I substitute -3 incorrectly, okay, I get a true statement. It's true that 1 is equal to 1. Woohoo! Okay, avoid that common error. Okay, let's go ahead and take a look at the next one. Is 1 a solution to 5y minus 7 over 3 equals to -4? Probably it'd be better for me to say the difference between 5y and minus 7 over 3. Just to say that I'm dividing the whole thing. But that's another day's lesson. So let me try and substitute it in. So my 5 stays a 5, but my y turns into 1. Look, I use parentheses again. You say, Kate, that's not a negative number. No, it's not. But see how 5 and y were shoved together? They're multiplying, and I need some kind of symbol to say multiply. Okay, parentheses are very versatile in math. We use them for groupings Here they grouped negative and 3 together, but we also use them to say multiplication. Okay, so 5 times y minus 7, and we'll put that all over 3. And the question I'm asking, is that left-hand side equal to negative 4? All right, so this is really where I need to do the math. This is just my math grammar, writing in complete sentences. Okay, so you can do it by hand if you want to. That's cool, but I think I'll do it by hand this time. But you can type this entire thing into your calculator, you guys, if you just put n over d first. You have to use the n over d button first, and then you can type that entire expression up top and then the 3 on the bottom. But that being said, this one isn't too hard to simplify by hand, so I think I will. So the top of a fraction does make a grouping. So I'm going to start up here on top. And there's 2 operations I see up there, multiplication and subtraction. I'm simplifying right now. I'm obeying the signs. So I will multiply before I do my subtraction. I have not yet divided by 3, so I'll drop that. There's still more work to do up there with the 5 minus 7. Let's see. If I only have 5 things and I take away 7 of them, careful, a lot of students struggle with negatives, but I only have 5 things. I take away 7. So I'm going to take away my first 5, and then I still have to take away 2 more. I'm going to end up in the hole at negative 2. Negative 2 over 3. Now, fraction bar means divide. Yes, this is the same as negative 2 divided by 3. But if you type that into your calculator, you get this ugly decimal out. Mathematicians don't like ugly decimals. We'd rather leave it as a fraction in most cases, especially when I'm doing pure math. Okay, guys, if it's not a word problem, if it's not a geometry problem, it's just pure math, I like fractions a lot. Okay, so, but remember the question I was asking, is this left-hand side equal to negative 4? Well, tell me, is this left-hand side, after I simplify it, equal to negative 4? Heck no, it's not. Okay, so when I plugged in 1 for x, I got a lie. Negative 2/3 does not equal to negative 4. And so therefore, is 1 a solution? Well, no, it's not. It is not.